Good day to you, my listener, and welcome to another episode on online logic and critical thinking. If this is your first time on this channel, please visit our previous episodes for a catch-up. For up-to-date lessons, please like, share, and subscribe to our channel. In this episode, we shall be learning the logical connectives as foundation to derivation in formal logic. If there's any part of this lesson you don't understand, please use the comment box below to ask your questions, as I will be answering them as time goes. Thank you. We may ask, what are logical connectives? What do they entail? How are they employed in statements? And what truth values are associated with these connectives? Logical connectives are essential components in logic, which is the study of reasoning and argumentation. These connectives help us to combine statements and manipulate their truth values. There are 5 major, fundamental, commonly used logical connectives in classical logic, and they are conjunction, which is denoted by the word and, disjunction, which is denoted by the word either or, negation, which is denoted by the word not, implication denoted by the word if, and biconditional, which is denoted by the word if and only if. Conjunction, as the first connective, is a logical connective that represents the operation of the word and in our logical statements or propositions. This means that wherever the word and is used in our statements, it means there is a conjunction, which is showing the togetherness of at least 2 propositions. In symbolic logic, the word and is denoted by the symbol of V in an upside down position. And for example, if we have the statement, it is raining and the ground is wet. To put this in symbol, it will become P representing the first statement and Q representing the second statement. Then we'll have P, V upside down, Q. And this is said to be a conjunctive statement where P is the first conjunct and the Q is the second conjunct. Please note that truth value means the truthfulness or falsity of a statement. What is the true value of a conjunction in formal logic? For us to have a conjunction which is denoted by the word and in a sentence, the truth value will mean that it must be the 2 statements are true together. In our example, we have it is raining and the ground is wet. For us to determine the truthfulness or falsity of this statement, it must be the case that it is actually raining and the ground is wet, which means a conjunction is true when the two conjuncts are true together. So it will be false if it is raining and the ground is not wet, or the ground is wet and it's not raining, because the statement says it is raining and the ground is wet. A disjunction also shows the relationship between propositions or statements. However, it expresses a situation where at least one given proposition is true. It's a logical connective representing the operation of or. The symbol used to denote disjunction is the V alphabet. For example, it is raining or the sun is shining, and it's represented with PVQ, where P is our first disjunct and Q is our second disjunct. First disjunct, it is raining, and Q, second disjunct, sun is shining. To know the truth value of a disjunction, since we are looking for a situation where at least one of the proposition is true, then a disjunction is false when the 2 propositions are false together. What this means is that if someone makes a statement, it is raining or the sun is shining, if it is the case that it is raining and the sun is not shining, a disjunction is still valid because it's saying either or. If it is raining and the sun is still shining, it is still permissible because at least one of them is true. But if we have a situation whereby it is not raining and the sun is not shining, then a disjunction is false because the disjunction is defeated. A negation is one of the simplest connective we have in formal logic because it's a fundamental concept that involves the denial or opposition of a given proposition, such that if a proposition is true, its negation is false, and vice versa. It is a logical connective that represents the operation of not, which is represented by the symbol tilde. For example, the statement, it is not raining, is a clear negation of the proposition, it is raining. And if we put this in logical statements, it becomes it is not the case that it is raining. If we replace our it is not the case that with its logical symbol, which is a tilde, and the proposition it is raining with the variable p, it becomes tilde p. In formal logic, the primary purpose of a negation is to express the opposite value of a statement. A conditional, also known as implication, is also a logical connective used in formal logic to model cause and effect relationship between propositions. This means that anywhere in our discussion that the word if is used, a conditional statement can easily be identified. In logical statements, it is called if and then. This connective is symbolized by the forward arrow symbol. Thus, in a conditional statement, the first proposition introduced by the word if is called antecedent, while the proposition introduced by the word then is called consequence. What then is the truth value of a conditional statement? A look at this example: if it is raining, then the ground is wet. A conditional statement is true in all cases except in a situation where the antecedent is true and the consequence is false. And that is a situation where it rained and the ground is not wet. In this case, we said it's false if that happens. The instances where a conditional statement is also true is if it doesn't rain and the ground is not wet. It means the statement is still true. Also, if it doesn't rain and the ground is wet, the statement is also true because it has not faulted the agreements of the antecedents. It is only when the antecedent is present and the consequence is absent that a conditional statement is false. Biconditional is the fifth logical connective that asserts the equivalence between two statements. A biconditional is typically expressed in the form of if and only if. The symbol used to represent a biconditional is the double-edged arrow symbol. For instance, in the example given below, I will go to the beach if and only if the weather is sunny. What then is the truth value of a biconditional statement? In formal logic, a biconditional statement is true when antecedent and consequence are true together or false together. Any other case outside these two cases is false.